Okay, now we're going to run the correlation matrix first. So we'll go data, data analysis, correlation. Okay, so now we've set up the data. So we'll start from the y variable, the difference in y. Okay, and then up to difference in 7. Now we're going to use only the estimation sample. First row is label, and we'll put the output starting from right here. So now we have the correlations. So we'll do some formatting here. Okay. Now the first column consists of the good correlation, because these are the correlation between the x variables and y, and all other correlations are bad correlations. And as you see, there are not a whole lot of them which are high. There is only one, that's the correlation between dx of 1 and dx of 2, which is kind of high, and there is one more here, dx of 1 and dx of 6. But let's run VIF and then see what that looks like. And we need to do that only for the x variables, only those. Okay, and we shouldn't use the y variable in VIF computation. So this is what we're going to be looking at. So highlight these 7 cells and then do VIF, and where are we? Okay, right here, starting from there and ending the last column over there. So close parenthesis, Control Shift Enter. So that gives us the VIF values, and when we examine the VIF values, everything, all of them are less than 10, which is not what we got previously when we did not do the difference. So the difference has done the trick here. It has eliminated the multicollinearity problem. Let's see whether we run the model building, we are able to get better results than the first time when the best model that we developed still had very large MAPE, like 19 to 20%. Okay, so now we're going to keep all of the variables, okay, and then we will run stepwise. So make sure that our y range is the difference in y, and we will include dy sub 1 or sub t as in the first as the label. The first row will be label, and then the x range is the rest of them. Okay, starting from there till there. Okay, so our first output range is going to be, let's put it here, and this is forward selection. So we select forward selection and we'll use 0.05 as the alpha to enter, and click OK, and that gives us a model with only dx2, only one variable. Okay, now let's run backward elimination. Okay, click stepwise. Okay, everything else is, the x range and y range are going to be the same. We have to change the output range to that and select backward elimination and do 5%. Now we start with the entire data set and we remove one variable at a time, and this time the backward elimination gives us the model with 3 variables, dx sub 1, dx sub 2 and dx sub 6. Okay. Now one more we'll do stepwise. Okay, output to go there, select stepwise, and again 5% and 5% as alpha to enter and alpha to remove, and now this gives you only d sub x2. Okay. Now we can develop all possible size models. Okay, and we really don't need it for this time, so just as an illustration, let's go ahead and do it. This is only for the purpose of illustration. I'll put it, the output will go there. Now forward selection, and you enter a value of 1 for alpha to enter, then that will generate regression models, 1 for each size. Okay. Now let's go ahead and summarize the information that we have, and we won't use the last one. We will only use models 1, 2, and 3. Okay. The forward selection, the model was with only dx sub 2. Okay. And r squared was model r squared, and model standard error was P28, so that's your model standard error. Now backward elimination, okay, gave us a model with x sub 1, x sub 2, and x sub 6. And the r squared value there for the final model is 51%, and 11.04 is the standard error. Now stepwise gives the same model as with the forward selection, so we can simply repeat what we have up there. Yeah. So this is our summary, yeah. And it looks like just one variable is just as good as 3 variable model. Okay, we can try both of them and see what happens to our holdout sample. But here, by the principle of parsimony, which says that if two models are almost equal, select the one that has fewer variables, less complicated, more simple. So here, since the standard error is pretty similar, the model with just one variable is almost as good as the model with 3 variables. So our inclination should be to go with just dx sub 2 as our model. But let's in the next video, let's consider both models and then see where that would take us.